Good evening, everyone. Welcome to Sustainable Ramona's second offering in our symposium series, the first being on water conservation and the next on transportation later in February. Sustainable Ramona is a grassroots gathering of folks in Ramona working towards sustainability for our community and surrounding areas. Tonight, we'll be asking the question, what is building electrification? This question will be fielded by Robert Carr and Tom Abram. Robert Carr, MA, LEED, AP O+M, LFA, is a consultant who specializes in making our region's built environment more sustainable. He's an LEED, AP, LFA, and a GPRO instructor and has used this experience to participate in many LEED projects with local organizations, including the San Diego Green Building Council. Robert also volunteers for the San Diego Building Electrification Coalition, SD 350, and the San Diego Green New Deal Alliance to advocate for just, equitable, and sustainable communities for all. Tom Abram, PE, LEED, AP, CEM, is committed to redesigning our worlds to become more sustainable. Tom has experience in energy audits, analysis, climate action, planning, sustainability, management, decarbonization, electrification, and green building design. He's interested in working on creative and cooperative approaches to dealing with environmental issues and improving quality of life. Earlier, the guys said that they will be speaking about building electrification, energy audits, analysis, climate action planning, sustainability management, decarbonization, and advocating for the sustainable communities. So let's take it away.
Okay, I'm going to go and start sharing my screen. Just let me know if you see it. So presentation. Okay, so we're here. Tom and I are both volunteers for this San Diego Building Electrification Coalition. It's quite a mouthful, but the SDBEC for short. And we're here to talk about what is building electrification, how you do it, why it's important, and so forth. So as we said, please remain muted. If you have questions, put them in the chat so we can get to them at the end. There's quite a bit of question and answer. And then this presentation is recorded, as you saw. So what I'm going to do is I'm going to introduce the SDBEC, and then I'm going to explain at a very high level what is building electrification. We refer it to as BE, so that's the acronym for it, why we need it. And then Tom's really going to go in there and talk about the technologies that are needed to electrify buildings, both in residential and commercial buildings, and really kind of go into kind of the more depth about what it all is. And then again, we'll finish with question and answer. So the SDBEC has literally been around for 1 year. It's almost our birthday. So it was formed in November 2020 to advocate for building electrification. We're a coalition of community members of all different kinds of groups, business, faith, justice, environmental organizations. We're working with labor as well to try to see if they want to work with us or join with us. We provide presentations like this to many different groups to kind of talk about the concept of building electrification and what they can do about it. And then we're also reaching out to cities and electeds to advocate for building electrification REACH codes. So REACH codes are codes that go beyond the current Title 24 energy codes. So this has been done quite a bit in our state. There's 50 or more cities that have actually gone beyond the current energy codes to have some sort of building electrification code on the docket. So we're trying to get cities to do that here in San Diego, and just recently the city of Encinitas did that, and Solana Beach is voting on one today. So that's really, really great. And so what we're really talking about is new construction initially. We want to make sure that no new gas infrastructure gets basically put into place because essentially it'll be stranded, because ultimately we need to get ourselves off natural gas. So, and then down the road, start talking about existing buildings, because that's going to be far harder. As you can see, we've got a really diverse group of members, coalition members, all very, passionate about what they do, and it's quite broad. So, without them and this, this broad coalition, we wouldn't have the success we've had. So, feeling pretty good about that. So I'm going to start kind of like a 10,000 foot level, very high level of what building electrification is. Quite simply, it's replacing all appliances that use natural gas in buildings with electric equivalents. So the three main things we use natural gas for in buildings are space heating, water heating, and then cooking and then obviously clothes drying as well. So the technologies to do this already exist. Heat pumps, which is on the right, those are mini splits right there, have been installed throughout the world for a long time, and it's getting much more popular here in the United States. So instead of using natural gas to heat the air, they actually take the existing energy in air and just transfer it into the house. Same thing with water heating. Tom's going to get into this, but essentially there's energy in the ambient air, and you're just transferring it using refrigerant to water. And it's just really that simple. They're super hyper efficient. And then in the middle here is a one cooktop burner of induction cooktops. So back in the day, everyone really didn't like cooking with electricity because those electric stoves really were not very fun to cook with. And so induction is not your grandmother's cooktop. And Tom is going to go into how this works, but they have lots of controllability. They cook so much faster than gas stoves. And you don't have all that really bad health effects from cooking with gas indoors. So why is it so important? Well, as we know, we need to start reducing the amount of emissions we put into CO2 and methane into the atmosphere. Many cities have really strong climate action plans and GHG reduction targets. And none of those can be met unless you actually deal with the emissions associated with buildings, essentially. And methane gas is one of the main things one targets. Health benefits. If you have a gas stove, please turn on that vent that should be above it. Because when you burn natural gas, the byproducts are nitric oxides. There's fine particulate matter. There's formaldehyde, among several others. All of which have bad health consequences, especially if it's not vented to the outside. You're talking about lung issues, asthma, cardiovascular issues. The list goes on. It's quite extensive. So if you do cook with gas, please use your vent. Use your vent and open the windows. And then when you get a chance, use induction cooktop stoves. Lower cost, when you build a building, if you do not have to install the gas infrastructure from the main line, wherever that is in the street, to the building and inside the walls, you're saving money. It's just you don't have to install that infrastructure. They're also, because of the increased energy efficiency of the appliances, they are cheaper to operate and run over their lifetime. Right now, there's lots of talk about natural gas being cheaper than electricity, but if you pencil it out, it's actually not the case in most situations. So, and then finally, the public safety of using methane gas in buildings. You have to extract it somewhere in the world. You have to process it. You have to ship it. You have to store it. You have to deliver it. And all along those lines, there's leakage, possibility for fires. So if you remember the Aliso Canyon fiasco up in LA, where there was a big storage facility for, I think it was SoCal gas. I can't remember. Anyway, there's all this tons and tons of methane gas are being released in the atmosphere. Tons and tons and tons were released. We also live in earthquake country, so when you have an earthquake and you have a gas line that shears or breaks, and you have an ignition source, you got a big boom. That's pretty hard to control. So there's, without the natural gas in buildings, a lot of those worries and fears and dangers kind of go away. So, these are all really good reasons why we should be electrifying our buildings. So in this pie graph on the left-hand side are all the emissions by sector in California. Obviously, transportation is by far the biggest emissions source here in California, but buildings are number 2. And of that 25% about, a significant portion of that is because we use natural gas. And so on the right-hand side, if you blow up kind of what the emissions are associated with natural gas, it's because of water heating and spacing. Those two are predominantly what use natural gas the most in buildings, followed by cooking, residential clothes drying, and some other uses. Altogether, 10% of California's emissions are due to using natural gas in buildings. So theoretically, if we electrify our buildings, we could potentially get rid of 10% of our emissions just right there. There's a lot to do, of course, but that's a big chunk of emissions that is really important to go after, and that's why we can't reach our GHG reduction targets without it. And this is the last slide before I hand it off to Tom. So currently, right now, this was 2019. I think this is higher for sure. An estimated of California's electricity comes from renewable sources, all right? And that should be up to 60% by 2030. And on the right-hand side, it shows that 63% of the energy in California is carbon-free. So what is carbon-free? Carbon-free includes renewables, but also includes hydroelectric and nuclear, because neither of those two are renewable, but they are carbon-free. So if you add all that up, you've got 63% of our power is carbon-free, with it 100% being the goal in 2045. So if we can deliver renewable carbon-free energy to electrified homes and all the buildings electrified, theoretically, we can bring those emissions down to close to zero. So that's why it's so important. If we electrify our buildings and we clean our grid, that's how we get these emissions associated with buildings going away. So I'm going to go ahead and stop sharing, and I'm going to let Tom take over from there.
All right, thank you, Robert. Let me advance this. All right, so I'm going to talk about each of the different areas of electrification in terms of what components you might electrify within a building. So starting with space heating, typically when we're talking about electrification, for space heating, we're talking about heat pumps. And so heat pumps are moving heat from the outside to the inside. So even when it's cool outside, there's still heat until we bring that temperature all the way down to absolute zero. There's still something we can squeeze out of it. So at the end of the day, it's moving heat from one place to another. It's basically, and it is an air conditioner that runs in reverse. It's effectively 250 to 400% efficient, depending on climate conditions and model. This is several times more efficient than a natural gas furnace, which theoretically, maybe get up to 97, 98% with a high efficiency condensing furnace, or an electric resistance heater, which is 100% efficient. So we're not converting one type of energy to another. We're just moving heat from one place to another. So we're able to get these really high efficiencies. So with a space heating system, especially if we're talking about existing systems or kind of traditional systems, you might have a centralized system with a gas furnace providing heat. A lot of times in San Diego, we've got distributed systems where we might have wall furnaces or baseboards or mini splits. And then we may or may not have a system that's paired with air conditioning. So if we're looking at doing a replacement of a gas unit to or propane to electric, typically maintaining the same distribution system is going to have the lowest upfront cost. If we already have central heating, then it's probably going to be the least cost to swap it, your furnace with a heat pump. So what does it look like? Well, in residential space heating, when you squint, it looks exactly the same as a lot of traditional systems. So if you have a furnace and an air conditioning unit, if you have an outdoor split unit, then when you electrify that, either in an existing or a new application for a central system, it's basically the same. It looks basically the same. All you've got is a reversing valve at the heat pump that lets the refrigerant flow backwards, and we don't have the furnace and the air handler. So this is what would be called a box swap, basically a 1-for-1. If you've got an existing and you want to electrify, this is a great option. There are some other options available, especially if you've got a situation where you might have wall furnaces and window air conditioners, or even in some cases, if you got a central system, these ductless mini splits are very efficient. So you can get Sears, seasonal energy efficiency ratio for these mini splits at 20 or more. It's oftentimes a lot more efficient than the central systems. And you get a little bit more controllability too. They do tend to be more efficient. And you could put multiple indoor units on one. For kind of lower costs, if you got window air conditioners, let's say, especially if in rental situations, an easy swap is just a window heat pump. So they have heat pumps that are window units that just go backwards. These aren't nearly as efficient, but they are a lot lower cost, especially if we're looking potentially at rental units, let's say, for a swap. When we look at the greenhouse gas comparison of these, looking at the CO2 equivalent for a natural gas furnace and electric resistance and heat pump, if we're trying to provide one therm of heating to a space, a natural gas furnace is going to be on the order of 14 pounds of CO2 equivalent per therm. Electric resistance, even though they've kind of been the bad boys of heat in California and elsewhere, from a carbon perspective, they're less carbon intensive now because the grid has gotten so much cleaner. So they beat a gas furnace, but we could do better. We could go down to a heat pump with what's called a COP of 3. That means it takes, for 1 unit of electricity, you could move 3 units of heat. So a lot more efficient than other options. And the beautiful thing about that is now that it's electric, you could eliminate those carbon emissions by using on-site solar as well. So once you pair your electrified system with solar, you could negate your carbon emissions. One thing I'll note: this doesn't include fugitive emissions. With natural gas, and upwards of 3% is being is lost as leakage, and methane, especially in a 20-year window, is 85 times more impactful than carbon dioxide on a per molecule basis. There's a lot of question to what that leakage rate actually is, anywhere between 1 to 3%. But it is important to keep in mind that we need to be able to addressing those emissions too. Moving on to commercial systems, a lot of times we have units that look exactly the same as the residential. We've got split systems that provide cooling and heating. We also have package units where we've got heating, cooling, and ventilation all in one. So we're bringing in fresh air, and we're also providing heating and cooling to spaces. The heating on these could be natural gas, they could be electric resistance or heat pump. The majority of them in California are heat pump already in terms of what's out there. So we're already using a lot of heat pumps, at least on commercial spaces. These are really simple and cost effective to electrify. If you got a package unit, it's basically a 1-for-1 swap when it's time to replace that unit. Other options are VRF or VRV, variable refrigerant flow or volume. Very similar to these split systems, but it's got multiple indoor units being fed by one outdoor unit. The nice thing about this system is it can be in cooling and heating mode at the same time. If you've got a commercial building where you might have a lot of heat load in one space, you need cooling, but you might have another area that needs heating. You could actually do heat recovery where you're essentially moving heat from one interior space to another interior space. There are some associated emissions from refrigerant leaks, depending on the type of system that you need to be careful about with these as well. When we go to larger units, larger buildings, we tend to see heating and cooling that's distributed via water throughout the facility. That's traditionally done from a heating perspective with a natural gas-fired boiler. And then with cooling, we've got a chiller, electric chiller, either air or water source. When we electrify these larger spaces, we tend to use, again, some sort of a heat pump system. So it could be an air source heat pump, basically a chiller that can run backwards now. We also have heat recovery chillers that can provide both hot water and cold water at the same time, especially for larger buildings that might be using VAV reheat. Essentially, with some of these older or rather, pretty standard systems with hydronic, we have cooling towers that are evaporating the water. Basically, we're rejecting the heat from the indoors to the outdoors, and we're using a cooling tower to do it with less energy. However, that's a lot of heat that we could be using for something valuable when we need heating. So we could use these heat reclamation or heat recovery chillers to reject that heat to a hot water loop that we could then use for space heating. We could also use it to provide some heating for domestic hot water as well. Moving on to water heating, domestic water heating. So for residential, our friend here is the heat pump water heater. As Robert mentioned, they're extracting heat from the ambient air and then they're ejecting it to domestic water. A lot of these units do have backup electric resistance. Again, if we're able to run it in heat pump mode, we're probably running at 250%, maybe 300% efficient. When we move to electric resistance, we're bringing that down to 100%. Most of all the current units are 240 volts, but there are 120 volt plug-in styles coming out this year. If you already have an existing electric resistance water heater, you could put one of these in and reduce your electricity consumption on the order of 70%. If you have gas, then there are a little bit more challenges, especially while there's still 240 volts. That'll become a little bit easier in the future, but you'd have to think about some rewiring. There are some minimum space requirements with these heat pump water heaters. They like having a little space because they're pulling heat from the air. Another option to be able to handle that is by ducting that unit. So you could send that cool air elsewhere or pull the warmer air from somewhere else. Another electric option is the electric tankless. They do require quite a bit of amperage and are less efficient. Again, at the most, they're going to be 100% efficient. You do not have the standby losses, so there is a little bit of a benefit there, but on the whole, you're going to use less energy with the heat pump water heaters. And with the large current draw, depending on the size, it could be 100 amps just from the electric tankless alone. So it does become more challenging from an electrical perspective. The nice thing about these is that it can provide grid service or energy storage capability. So if you combine this with a smart plug or something of that sort, then you can, or a lot of them have integrated smarts to them. You can basically charge your water heater, heat your water heater when electricity is cleaner, when you might have excess solar generation. So this is a nice way to be able to help out the grid and encourage additional renewable energy. From a multifamily or commercial water heating perspective, an option could be distributed water heaters, one per unit if it's in a residence. And this is basically the same as the previous slide. You just have these heat pump water heaters, tank style, within each of these units. Another option might be a centralized hot water heating plant. This is a product that actually uses CO2 as a refrigerant. CO2, while is the predominant molecule responsible for climate change, it has a global warming potential of 1, whereas some of these refrigerants might be in the thousands. So from a refrigerant perspective, CO2 is a lot less less harmful to the environment. These are kind of interesting in that they make the hot water in these little units that look like split HVAC units, and then they store the water in a hot water tank. So this makes it a lot easier for retrofit situations as well. Another option would be a hybrid approach where you're kind of doing maybe a few water heaters per floor. From a cooking perspective, a lot of people don't care for electric cooking. This is one of the areas where we see more resistance. Some more resistance from certain stakeholders because people have this emotional attachment to their gas cooking devices, even though from a health perspective, it has the worst health impacts compared to some of these other devices in our homes. Nice thing is we do have these electric induction units now that are that cook a lot better. They basically generate magnetic fields and convert that to a current that gets converted to heat within our cookware. So we're basically heating that cookware directly rather than heating a coil, which then has to cook the heatware or heat the cookware. So it does end up being more energy efficient than electric resistance. It also turns off if you remove the cookware. You do need to have some. I don't like saying special because it's cast iron, it's enameled cast iron, it's a lot of stainless steel. You just have to make sure you're using the right cookware. Although there are plates you can get to allow any cookware to work. Really fast to heat. Ours, by the time I'm grinding my coffee beans, the water's already hot because these things just cook really fast, easy to clean, great control. We do have an electric home cooktop program at the San Diego Green Building Council. So you could go to ehomecooktops.com, check one of these plug-in versions for a couple weeks, 3 weeks, see if you like it, and whether it makes sense for you to convert to a larger unit. On the commercial cooking side, induction is great in that it improves the safety of workers in the kitchen. So it reduces the heat that's entering the kitchen space, and it reduces injuries that occur from open flame. There are technologies available beyond cooktops. So there's induction woks and deep fryers, steamers, bain-marie. This whole line here, this is all electric induction. Few different options on the dryer side. When we electrify, so there's kind of the standard electric resistance vented dryer. It's the most energy intensive of the electric options, but it is faster to dry. We also have various venting types, the standard kind of condensing dryers, which are more energy efficient. The neat thing about these is you could get combined washer dryer units that you put your clothes into one machine, it washes it, then it dries it for you. And then finally, our friend the heat pump, we have ventless heat pump dryers available now, which is going to be the most energy efficient. Next to you know, the sun, if you put your clothes out on a clothesline. In terms of managing our electric panel, as we're adding all these electric devices, this will increase the load on our electrical panels. So we want to make sure that that panel board can handle additional utility power and distribute it, you know, throughout the home. Some strategies to be able to manage that are, if we use high efficiency equipment, then we can, you know, reduce the size of the electrical service. With combined units, if we've got a combo washer dryer, or if we've got a range that combines the oven and the cooktop, then that reduces the electrical service as well. Right sizing our HVAC, we can do energy efficiency, envelope improvements. We can get a smaller HVAC unit. We do circuit sharing plugs. So this is pretty neat. There's this company, Split Volt. There's another NeoCharge. And it's basically a smart outlet. So for two 40-volt appliances. So you could put your dryer in one, your electric vehicle in the other. And when the dryer kicks on, the EV pauses the charging for a little while and then picks it up again when the clothes are dry. Let's see. There we go. So some tools for that, we could be looking at looking at hourly energy use before we have solar to kind of look at what our loads are. We could also use, there's a watt diet calculator that a guy, Tom Cabot, up in Menlo Park has developed to see whether you could, whether you need an updated panel or not based on electrical codes. And what really ties this all together is solar. So electrification allows you to be able to cover all of your energy use with solar. Rooftop solar improves the economics of electrification, especially in areas like in San Diego where we have high electric rates. When we pair it with rooftop solar, then we're able to offset all of. And when we pair solar PV and heat pumps, that typically ends up being more efficient than solar thermal, which of course there's still some great opportunities to apply solar thermal, especially in pools, etc. But the efficiencies are actually end up being higher because of that the coefficient of performance from the heat pumps being, you know, up to 3 or so. So just gonna run down and do a quick review of my home here, the eCorinthian. Our home is all electric. We shut off the gas at the end of last year. We're located in El Cerrito, 1,500 square foot. It's built in 1949, and we bought it right after a major remodel was done in 2015. So we moved in April of 2015. The first thing we did to electrify was put in a heat pump for our space heating. We did not have air conditioning at the time, and after a few weeks of a hot spell, we went ahead and put it in and made sure we selected a unit that was able to provide heating as well. Then we put in our initial solar array after we had a year's worth of data on our solar or on our energy use, and that was able to supply all of our electric needs until we got our electric vehicle, our plug-in hybrid Chrysler Pacifica. So this goes about 30 miles on electric before it shifts to gas, but that meets most of our needs here. And then another thing we did is, I like to call this electrifying on the cheap. This is that portable induction cooktop. So it, you just plug it in the wall and see if you like how an induction works for you. We liked it. We cooked on that for about 2 years as our primary cooktop. Put in a level 2 EV charger to be able to maximize the electric on the EV. Got a second EV, a used Leaf. And then put in our heat pump water heater right when the pandemic was kicking off. April of 2020. Had a hard time finding at the time contractors to put one in, so I ended up doing it with a friend, it passed inspection, and it's working fine. So do have this kind of odd white duct kind of sticking out of it. Since a lot of the water heaters in San Diego are in these sheds, doesn't have the best airflow for these heat pump water heaters. So what I did is I ducted it directly from the unit. It goes into our home through the attic and then terminates in a vent in our kitchen. So if we want free cooling, we have it. And if we don't want cooling, we can close the vent and it just relieves to the attic. Knowing that we were moving our last couple appliances off, we went ahead and expanded our solar array. It's a 6.5 kW system, supplies also, as well as our water heating, space heating, and standard electric devices, also our induction range and our dryer. And finally, in December of 2020, so just under a year ago, we shut off our gas. So we've got a couple, about 1 month. We had the solar for over a year. We haven't quite been all electric for a year, but it looks like we're going to be net positive from an energy standpoint. This is kind of a neat way to kind of look at what these solar panels are providing. So kind of the standard energy needs of the home are these 8 panels here. 1, 2, 3, 4, 5, 6, 9 panels. And then our kind of calculated at 2 of these panels for the first installation, provide our space heating. We needed about another 2 for our water heater, about 1.5 for cooking and drying, and then our electric vehicles kind of take the remainder of these panels. Tried to plan for this expansion knowing we were going to go all electric one day by putting in a larger inverter. So we did not have to change out our inverter when we added more panels. We did end up with some panels on the east side because there wasn't as much room for them elsewhere. Some of the lessons were, I might have gone with higher efficiency panels so that I can squeeze more on the south and the west. Would have liked to have upsized the conduit. They had to redo some conduit work because that was not upsized. So I think that's kind of key for a lot of this, is just kind of plan ahead. In your journey on electrification, you can loan out a portable induction cooktop. And if you like if you like it when you're borrowing it, you can pick one up. They're about $50 or $60 online. It's a great way to electrify on the cheap. Another thing I recommend doing is kind of determining how old is your water heater, your HVAC equipment, your other appliances, to help you determine your approach. Are you going to be replacing these upon failure, or are you going to expedite it? It's important to have that plan ready, because when your water heater goes out, you're going to want hot water. You also can prioritize based on overall impact from a cost, carbon, health perspective. From a cost perspective, I found that the space heating and the water heating had the highest savings, and quickest payback. and that kind of translates on the carbon side. You get a big carbon benefit when you shut off the gas too, because you reduce any potential methane leaks in the home. And then looking at health, obviously, cooking is a great one to prioritize. Want to strategize your electrical panel with needs for all electric. If you're doing it piecemeal, try and get that whole that panel planned out. Let the electrician know that this is what you're planning to do. We had them come out a couple of times. We probably could have cut out a visit if we had planned ahead. Size the solar with future needs in mind, and you could get some no-cost help. So if you click this link, bit.ly/helpmeelectrify, then it goes to our no-cost tech support through the San Diego Building Electrification Coalition. Our website is sdbec.org. You can find us on social media there as well. I'll leave that there. So thanks, glad to answer any questions, and we hope you join us in our coalition.
Hi, this is Joyce. I have a question, particularly about induction, because in 2007, we actually installed we bought an induction stove, and we had solar panels. And our issue was that it kept blowing out one burner after another, and we finally had to get rid of it. And I'm wondering and this was a relatively new house. I mean, it was less than 10 years old. And I'm wondering if the issue was we needed an electrical panel, or because we liked induction, we cooked with it, and my husband was a cook, not me. But we finally, I mean, the stove just deteriorated. I mean, just one burner after another just went out. And so I guess I'm just curious because I'm moving to another house, and I would love to. I basically have decided never to do induction again, but I'm wondering if that, but I do use electric, by the way. But I'm wondering if it's an electrical panel that we needed, or what was the issue?
Yeah, it's hard to kind of identify from afar. I mean, if the individual cooktops, they were going out, that just seems like you got a lemon, or just a bad product. I haven't heard of too many people having issues. I'm wondering if, since you were kind of on the cutting edge there, if maybe some of the earlier models weren't quite as robust.
That could be, yeah. It was a Viking, I believe, was the brand, which was they were the, as I understood it, they were kind of the pioneers, or a pioneer.
Yeah, that's kind of surprising that the Viking would go out. I mean, the electrical panel, if you didn't have enough service, the breakers would just flip, and so I'm wondering why the individual cooktops would go out.
It was one at a time. It was one
That doesn't seem like an electrical panel issue to me. I haven't heard of that, but yeah, my gut is just you ended up with a real bad unit. The good news, if some people like the electric coils and are fine with them, and so they're definitely they're cheaper, they're a little bit less efficient. I'd say I think it's somewhere like the electric resistance might be 60% and the induction might be 70. It's kind of about the numbers I've heard. So it's a little bit more efficient with the induction, but I would say if you, especially some of the newer flat top, fairly easy to clean because they're flat tops as well.
Right.
I'd say if that meets your needs, then I'd say that's fine. Otherwise, I haven't heard as the horror stories that you experienced recently. So I'm hoping that and we have ours is about a year old, and it's I think it's a Frigidaire, so it was kind of the lower end for the induction cooktops. We haven't had any issues, but a year in, you'd really hope not. But yeah, thanks for sharing that. That's unfortunate to hear.
Joyce,
And
we
I-
lost our home in the '07 fire, but I did a remodel, of course, a couple of years before the fire. And we put in Viking appliances. We had basically the same kind of cooktop, and we've been all electric since 1981. So that Viking stuff worked great. We did have 200 amp service, 200 amp panel. So that might have had something to do with it if you had a 100 amp or something less. But the
so-
Vikings worked great, although in recent years, they've kind of gone downhill.
And I assume you still have to have the special pots and pans.
Yeah, mostly for my wife buys the pots and pans for the environmental quality because there's so many surfaces that just leach all the bad stuff as you cook into your food. So she's pretty conscientious about that, but we've been cooking on electric so long that we've got everything already.
Yeah, and like the cast iron, which is better than from a at least from what I've seen from a environmental health perspective than like a coated pan. They work great on induction. They do have these like discs. It's literally just a piece of metal that you put on the induction cooktop, and then you put the pot on top. So it heats up that disc, which then heats up the cooktop. So a little less efficient. But if you've got like a favorite, cookware that doesn't work on induction, you could make it work. It's just going to be less efficient. It's going to act more like a coil.
Walter, Donna, do you have anything?
Well, it's Barney. Yeah, on ours, we have induction, and actually because we bought everything with all one brand, GE, and ours is GE profile, and it's well, since the beginning of fire, that we've since 2010, I guess. So we've had it for that long at the initial rebuild after the fire. Of course, the deal was buying a package like that made it a lot cheaper, and but we've had really no problem with that at all, and I like it better. We had before that, we used to have the Amana series where they had the pluggable modules that were electric. We've always been on all electric, so in our previous house, even it burned down there, but we had the pluggable modules. I liked those, but then in reality, it was a lot more complicated because it had a barbecue thing in it, which really wasn't a good idea to have inside your kitchen anyway. So anyway, so yeah, with the I think maybe it is something to do units, different ones, time when you did it, but we've had no problem with that.
And after our fire in '07, we eventually moved into the house we're in now, a 40-some-odd-year-old Adobe. I pretty much gutted the house, but we put Thermador units in the kitchen, and they're spectacular. They're just amazing. The refrigerator especially, it runs on 15 amps, and it's got 2 motors, and keeps things 4 times fresher than most reefers. It hardly uses any electricity.
That's great.
Robert and Tom, I just wanted to tell you a story because I'm probably for a lot. You're preaching to the choir with the folks that are here right now, but
Sounds like it, yeah.
especially me in 19. And Robert, I wanted to tell you, Ramona has no natural gas and never has.
So every building is all electric in Ramona?
Everything is propane or electric.
Okay, all right.
Yeah, there's a lot of time bombs sitting out in people's backyards all over this community.
I mean, the only good thing about propane is it's much less of a global warming potential issue if it leaks. I think it's much less than methane. But yeah, those tanks sitting out there in the fire zone isn't good.
Well, the story I wanted to tell you was in 1981. I had completed a new house. We lived in it 10 months, and we had a giant propane explosion because propane's heavier than air. Actually, I had a 83% burn. And so I've never used any gas since then. And we've been totally electric ever since. And I design and build homes, and I've probably installed 400 or 500 heat pumps through the years. And they're just wonderful. They just work great. And the new EER ratings are incredible. The house we're in now, we have 6 heat pumps, but we never use more than one at a time. So we have one in each bedroom. We each have a studio, and then we have a larger main split system heat pump for the main part of the house. But we only use one at a time. And there's no reason to be climate controlling all of your rooms except for the one you're in, especially if you don't have a large family still. And over COVID, I put in about a 14.8 kW solar system, actually in 2 parts. And since I energized it the last 5 or 6 months, we're putting 4 or 5 times more power into the grid than we're taking out. We ordered an electric car yesterday, and the winter will be more because an Adobe house stays really cool in the summer, and we travel in the summer. In the winter, we're here all winter, and we got to have that heat pump going. So it won't be quite as efficient. But next on the list is battery backup. But we're feeling pretty good because we're getting awful close to net zero.
That's great, Rob.
Yeah.
Love to learn about some of your experiences you've had with some, putting in these all electric homes. And one of the things Robert and I are working on is identifying contractors in the area who have experience with putting in space heating heat pumps, as well as heat pump water heaters and other electrification elements. We've had coalition members who have had a hard time when they're trying to do these voluntary retrofits, finding, qualified contractors. And so there's a list through Efficiency First California, they call it the Clean Energy Connection. They've got lists of qualified people. So we've been working with them to get some. There was only one, I think it was an electrical contractor in San Diego, but we didn't have any plumbers or HVAC folks on that list. So if you have any good experiences with contractors, or love to learn more about, why you do what you do. I think it sounds like I'm sure, very environmentally driven. But when we go to some of these, advocating for some of these REACH codes, there's some pushback on, and it's going to be more expensive to do it this way. Especially for new construction, it seems like the research shows that it ends up being cheaper first cost. So any experiences that you have and other folks in your group have, love to learn more.
Well, I started designing and building energy efficient homes in the mid 70s in Ramona. And for many decades, I was the only one pretty much. Why are you building out of 2x6 walls? Why are you using dual glaze windows? Well, greenhouses have caught on finally. And I just kind of bent the will of certain contractors I was using anyway. And they got really good at like I always would hold all the wiring and the ductwork. I'd make everybody put a platform up 13 inches high in the attic so that they didn't scrunch all that great R38 insulation is what I like to use here. So they didn't scrunch it all down and end up with an R10. So it's just making subcontractors aware, and there are more and more all the time. But you're right. Then there are those who just want to get the job done and focus on the cosmetics. It's just been the way, and I don't know how to get everybody turned around, but training and incentives, I guess.
Yeah, there's some good ones coming next year that for both existing and new, the tech program and build programs. So for heating, electrification, water heating. So hopefully that gets some contractors interested and excited.
I put that the link for the Clean Energy Connection in the chat, so go and have a look at that. We actually have 2 or 3 contractors that are going to be added to that list. So there'll be more people in the San Diego region that you guys can reference there.
Well, if I was younger, I'd sign up, but I'm going the opposite direction.
No worries. Yeah. So, I mean, anything we can ask, like questions we can answer about the coalition? Do you have any interest in joining the coalition? It doesn't really take much. Just say you'd like to join, and, you know, but,
I would think,
Go ahead, Joyce.
I'm not muted, good. I would think Sustainable Ramona would want to join, yes.
Right.
cool. So let me go and let me get the website. Tom, are you driving? Do you want to take them to the SDBEC website and then
Sure.
sign up? So it's pretty straightforward. You just put in your contact information, and then I think it's Kelly who'll reach out just to kind of confirm, and that's it. And then they kind of what kind of member you want to be, because you can just be just a you know an associate member where you don't necessarily automatically sign on to things that we do, or there's other members that what is it called, Tom, where they're a core member? Is that what the language we're using now? Where whenever we come out with some sort of policy or letter that we signed, you'd automatically be put on there. So Tom, right here, you can see here, you just go to let me see here. You got the website up?
Yep,
Yeah.
just shot it in the chat. The link to the
Yeah, so at the very bottom of our homepage, you'll see all our members, and then there's a link saying sign up your organization to join the coalition.
Okay,
And that brings up that Google form, I think, right?
Yep.
And then you just fill it out, and then we get back to you. Kelly Linden is our main person.
okay, and your website is,
SDBEC.org.
okay, that I got. Got it.
I wanted to mention one other thing to you guys. I've probably through the years installed 40 or 50, or had installed mostly, done a couple myself, solar hot water heating systems. And those are wonderful. They use the majority of them. The panels are above the tank, and they'll use like a little 1/40th Grundfos pump or something. So it uses electricity for a pump and for the differential controller, and then of course for the electric backup. But I've had solar hot water heating for years, and you turn it on for a couple months a year around here. The rest of the time you just leave the backup off, and it's free hot water except for that minuscule amount of electricity that the pump and sensors use.
I mean, I think Tom, we definitely are for any kind of technology that assists electrification. I think for instance, if you look at Tom's roof, if you tried to put solar thermal on there, you get pretty crowded up there with that big system he's got. And Tom, do you agree that sometimes that if you're putting a big solar panel system on your roof, that solar thermal might get in the way?
Well, in my particular situation, the only thing on the roof is the solar hot water system. I have a ground mount on one side, and actually I have a racked.
Well, in that case, that makes all the sense in the world then, because you're not fighting for roof space.
Well, it's nice clay tile. It's a hacienda style house, and you don't want it disrupting the look either. So, but there's a carport over on one side. I added 14 LG 360s there, and I've got 27 more on 100 and some odd feet away on the west side of the house in the ground mount. So 41 panels providing 14.8 kilowatts, and I just love to sit there and watch that meter spin backwards all the time. I know I'm giving free juice to SDG&E, but it feels good.
You get a little something.
Until I get the cars going.
Look it up.
Yeah, for sure. Yeah, you want to definitely reduce the amount you put on that grid, because especially with the new NEM rules, and hopefully NEM 3.0 is better than it's sounding to be. But the more you can use those electrons coming out for your use in-house than going to the grid, the better you're off. That's for sure. Coming
home and filling up just sounds so good. The news said tonight, some places in California, gas is over $6 a gallon.
Yeah, it's crazy. Yeah, I mean, every time I charge my car, it's exactly the same as the 3 days before that, and the week before that, and the month before that. I mean, obviously, our rates go up, periodically over, every year. Is it every year that they adjust the rates? Or do they have to, or is it going to be whenever, but they just have to get CPUC
Yeah.
approval?
Yeah, they've got to get that approval, but it can fluctuate a little bit. But
Well, Donna or Walt or Joyce, anything else? I hope I didn't monopolize the questions and comments too much here, but thank you guys very much.
Our pleasure.
That's
Thank
great.
you
I learned a
all.
lot. I wish there were more people here, but there will be more people that will be latching on to the recordings.
Great. Well, if you have any questions about how to sign up or anything like that, just reach out and we'll answer those questions for you.
I have a feeling Joyce is on it.
Got it.
Outstanding.
All right, nice to meet you all.
Yeah,
Okay.
nice to meet you too. Keep up the good work, guys.
Thank you.
Likewise. All right,
Take care.
cheers.
Bye-bye.
Bye.